All right, well, good morning, my pre-calculus class. As you guys know, it's Mr. Jensen, and I am teaching remote. I'm in my garage teaching lessons on the whiteboard. Hopefully at this point you have your notes out. You guys are going to be taking notes wherever you're at. And we're going to try doing this this way for a little bit. I hope it's kind of weird. It's kind of awkward for me as I'm talking to a camera and not live students, but I will do the best that I can. So try to do your best to follow along. Today we're going to be getting into our last unit that we really need to cover. So the verifying trig identities, trying to teach that and then do that quest for glory is really not going to work out for us. So what we're going to do is we're going to kind of press into the last unit. The last unit is called ST, which is for solving trig equations. What that means is normally we've been solving equations, and solving equations has been stuff where we would do like x squared plus 3x equals 5, and solving equations like that. Solving trig equations, what that means is we're going to take equations with sine, with cosine, and put that stuff together with x's and try to solve that for x. In order to do that, we need to kind of get a couple of formulas that we haven't learned out there. And so we're going to start today with our sum and difference formulas. On that pink sheet that I had all those formulas on there, at the bottom of that pink sheet there's the sum and difference formulas, and you'll notice there's 6 of them. Normally, when we're in normal school and we're in the classroom, I spend a full day proving just one of those formulas. It takes me about a full period to prove one of the sum or difference formulas, and the rest of them follow from that. Because we're doing this remote style today, I'm just going to give you the formulas, and I know that hurts my heart, and I know it hurts you at home a little bit, but hopefully you'll get over it. But in case you're missing that pink sheet, let me show you the 6 sum and difference formulas. The first one is sine of u plus v. We call this a sum formula because it's adding, and u and v just represent 2 angles. Think like 30 degrees and 45 degrees, or think like pi over 6 and pi over 4. Something like that. Sine of u plus v. And here's what the formula, here's how this breaks down. That if we have 2 angles being added, it can break down into sine of u cosine of v plus cosine of u sine of v. And I know it looks complicated, but we'll get more familiar as you use it a little bit more often. That we have a difference formula for sine, which is sine of u minus v. We call this a difference formula because obviously these 2 angles are being subtracted. And so here we're going to be, the formula is going to look exactly the same, except that instead of a plus here, it's going to be a minus here. And so this turns into sine of u cosine of v minus cosine of u sine of v. From there, we have our sum and difference formulas for sine. We have 2 for cosine and we have 2 for tangent. For our cosine one, I have cosine of u plus v, which is equal to cosine u cosine v minus sine u sine v. And then cosine of u minus v is equal to cosine u cosine v plus sine u sine of v. So one of the ways that sometimes students try to remember this is if you remember, notice all the u's and the v's kind of line up exactly the same order every time. U, V, U, V, U, V. If you can remember that sine goes in the order sine, cosine, cosine, sine, and that cosine goes in the order cosine, cosine, sine, sine. Sometimes students find that helpful. The other thing that students find helpful, in my own way that I remember this, is that sine, and this will go with calculus as well, sine is so happy. So that means that if there's a plus here, because sine is so happy, that there's going to be a plus here, that the signs don't change, okay? Sine doesn't want to mess anything up. That if it's negative here, it just stays negative, and that's okay. But cosine, I think of cosine as cranky, okay? Cosine very, very cranky, and so a positive sign turns to a negative sign, and a negative sign turns to a positive sign. Cosine just wants to mess everything up. Last but not least, we have our 2 sines or 2 cosines. We need our 2 tangents. That would be tangent of u plus v, which would equal, this one's going to be a fraction, it's going to look a little bit scarier. It's going to be tangent of u plus tangent of v divided by 1 minus tangent of u times tangent of v. Okay? Then on the second one here, we have tangent of u minus v, which will look exactly the same here, except these 2 signs are going to change. So that'll be tangent of u minus tangent of v divided by 1 plus tangent of u times tangent of v. The way that I help remember the tangent one is that if you remember that tangent was sine over cosine, that on the top sine, remember sine is so happy, so the signs will stay the same, over cosine, so in the denominator it's cranky, so it's going to change, it's going to be the opposite sign here. Notice sine is so happy, it'll stay the same, and then cosine is cranky, it'll change the opposite sign. So these are your 6 sum and difference formulas. Hopefully you have that pink sheet, it's still on there. If not, I can attach that PDF on Schooloo. But you'll need to know these 6. And then today, what our notes are going to look like today is that we're going to use these formulas to kind of evaluate sine, cosine, and tangent of various angles going forwards and backwards. Because I'm limited on board space, you're going to see me do is just kind of erase this and then start my next problem. Alright, so getting into our first example, here's our goal. We're going to try to find the exact value of, what are we doing today? Cosine of 75 degrees. Now, if I want to find cosine of 75 degrees, what we're going to quickly realize is that if we don't have a calculator, 75 degrees does not fall on our unit circle. Like, we know what cosine of 30 degrees is, or 45 degrees is, or 60 degrees, but 75 isn't one of those angles on our unit circle. So what we're going to do is we're going to pull 75 degrees apart into 2 angles. So we need to think of 2 angles that either add to or subtract to 75 degrees. And we want to pick 2 angles that we have information about on our unit circle so that we can evaluate it. So those 2 angles that I can think of then would be 45 degrees and 30 degrees. Okay? So I'm going to break this down as cosine of 30 degrees plus 45 degrees in parentheses. When I do that, notice this. Okay? Notice that 75 degrees is still equal to 30 plus 45. Okay? And that now I have a u and a v. Please don't make the mistake. Some people think that they can just distribute the cosine and evaluate those. It doesn't work that way. At this point now we need to use the sum formula for cosine. So you're going to look at that pink sheet or back in your notes, and you're going to look up the formula for cosine of u plus v, okay, which is what we have here, 30 degrees representing the u and 45 representing the v. And you'll see that this was equal to cosine u, cosine v, minus sine of u, sine of v. Okay. So when I do that here, my u again is taking on the 30 degrees and my v is taking on the 45 degrees. So this will equal cosine of u, 30 degrees, times cosine of v, minus sine of u, times sine of v. At this point now we've used the formula, and all we have to do now to get this value is to evaluate each of these individual numbers on the unit circle. Again, I like to use the left-hand rule, so I'm going to do that. For cosine of 30 degrees, if I pull back 30 degrees, cosine is the value on top, so that's going to be radical 3 over 2. Cosine of 45 degrees is the x value there. That's the value on top again, which would be radical 2 over 2. Minus sine of 30 degrees is the y value, which is 1/2. And sine of 45 degrees is going to be radical 2 over 2. At this spot now we want to multiply our fractions. Remember, when we multiply fractions, we multiply across. Radical 3 times radical 2 is radical 6. 2 times 2 is 4. Minus 1 times radical 2 is just radical 2. Over 2 times 2 is 4. If we have a common denominator, we can add and subtract fractions. When we do that, we just subtract the numerators in this case. So I get radical 6 minus radical 2, all divided by 4. Every once in a while you'll see people factor out a radical 2. We don't need to do that. I'm totally content with our answer stopping right here. And so you'll notice here's what we did. We were able to take an angle that we had no idea what the value of cosine of 75 degrees is. We were able to break it into 2 angles being added to 75, use a sum formula for cosine to break it down to get an exact value of cosine of 75 degrees. And this is how we use our sum and difference formulas. Again, I'm going to move forward and erase this. If you need to pause it to copy it down, that's totally fine. And then we'll move on. As we're moving on into our second example, what I'm going to start doing is I'm going to put up examples for you guys. And what I'd like for you to do at home is to write down the example, and then I'm going to say pause, which means I want you to pause the video here, and I want you to try the example just kind of like I would do in the classroom, where I would say, hey guys, try this problem. And then if you finish the problem or you get stuck, then feel free to hit play back on the video. This is still, I think, one of the best ways that we get to learn is by trying the problem on our own and seeing where we get stuck. So let's try this on problem number 2. Number 2 is we're going to try to do sine of, parentheses, negative 15 degrees. So again, at home, try to think of two angles that add or subtract to negative 15 degrees. And those two angles should be angles that we have information about on our unit circle. So go ahead and hit pause, try this problem, and then welcome back right whenever you guys are ready. Alright, welcome back. Hopefully you guys got it. If not, let me help you guys out. I know that two angles that would subtract to negative 15 degrees would be 30 degrees minus 45 degrees. Now it's possible I could have picked other angles like 45 and 60, and it turns out you'll get the same solution at the end. But these are the two that I chose. At this point now I need to remember my difference formula for sine. My difference formula for sine was the sine of u minus v, because I chose two angles being subtracted. And that would be sine of u cosine of v minus cosine of u sine of v. When I do that, this will break down to sine of my u taking on the form of 30 degrees, cosine of v taking on the form of 45 degrees, minus, got it. I almost messed up. We got it. Remember, cosine is so cranky, and so it changes. This is sine. Oh, no, what am I doing? Look at that. In case you thought this was all edited and perfect, it's not. There's my confirmation. Sine's so happy he's not changing the symbol here. Okay. And so this will be cosine of 30 degrees, and then sine of 45 degrees. Sorry for that. At this spot here, we've broken it down. Now we're just going to evaluate all of these on the unit circle. I'm going to go a little bit faster on this part of it. So I get 1/2, I get radical 2 over 2, I get radical 3 over 2, and I get radical 2 over 2. Again, we're going to multiply these fractions, and I should get radical 2 over 4 minus radical 6 over 4, and I should get radical 2 minus radical 6 all over 4. So at this spot here, this is what sine of negative 15 degrees. Hopefully this is what you got at home. If you didn't know how to do a thumbs up, you can do a thumbs up back to your screen. If you feel awkward about that, then I don't know, don't do that. But this is problem number 2. We're going to move into our third example for today. So problem number 3 we're going to do is kind of similar, but a little bit different. It's tangent of pi over 12. Now the difference obviously is not only are we using tangent, but pi over 12 is a radian measurement. And so we need to think of two angles that add or subtract to pi over 12. That's going to be a little bit more difficult for us because us adding and subtracting fractions is harder. So what I encourage students to do when I'm first teaching this is take the radian measurements we know, like pi over 6, pi over 4, and pi over 3, and convert them, all those fractions in terms of pi over 12 in this case. So if I do that, if I take pi over 6, and if I wanted to convert it to pi over 12 stuff, what I would do is I would multiply this fraction by 2 over 2. And that would give me 2 pi over 12. And if I do that with the other radian measurements that we know on the unit circle, I could do that with pi over 4. Which then in this case, I'm going to multiply this by 3 over 3. And that would turn this one into 3 pi over 12. And lastly, I would do the same thing with pi over 3. and I'd multiply this by 4 over 4, because when I multiply that, this turns into 4 pi over 12. So when I do this and I get this set up, I have this all in terms of pi over 12s. And when I get this all in terms of pi over 12s, I can think of two different angles that I'm going to add or subtract to get to 1 pi over 12. In order to do that, you could either choose pi over 4 minus pi over 6, or pi over 3 minus pi over 4, because either one of those would result in subtracting to get 1 pi over 12. So when I do that, I'm going to choose pi over 4 minus pi over 6, and so I get tangent of pi over 4 minus pi over 6. Noticing pi over 4 was 3 pi over 12, and pi over 6 was 2 pi over 12. So when I do 3 pi over 12 minus 2 pi over 12, I get 1 pi over 12. At this point now, I'm going to use the tangent difference formula for tangent of u minus v. I'll write that down here. Remember, tangent of u minus v, that was equal to tangent of u minus tangent of v divided by 1 plus tangent of u times tangent of v. At this spot here, I know that my u is my first angle, which is pi over 4, and v is my second angle, which is pi over 6. So at this point, I'm going to do tangent of pi over 4 minus tangent of pi over 6 divided by 1 plus tangent of pi over 4 times tangent of pi over 6. At this spot, I need to evaluate each of these individual trig expressions from the unit circle. I know it's a little bit annoying because the tangent one's one of the ones we're not a big fan of, but we can get through. Tangent of pi over 4 is one of the easier ones. That's going to be the y over the x value. Remember, tangent is y over my x value. And so y over my x value at pi over 4 is going to be radical 2 over 2 divided by radical 2 over 2, which is just 1, minus tangent of pi over 6. Well, that's the y over the x value. So the y value at pi over 6 is 1/2. So 1/2 divided by radical 3 over 2 will turn into 1 over radical 3. Divided by, down here, 1 plus tangent of pi over 4 is 1. And tangent of pi over 6 is 1 over radical 3. If I simplify this a little bit, I get 1 minus 1 over radical 3 divided by 1 over, divided by 1 plus 1 over radical 3. At this spot, this looks kind of messy because we're in the spot of having fractions and fractions within fractions. Now, unfortunately, back in our verifying trig identities, I was going to start showing us some moves that maybe you've seen in algebra with some trig stuff, but maybe you haven't seen this algebraic move. An old algebraic moves that we used in rationalizing rationalizing fractions, as you guys would old school, is get a common denominator here, a common denominator here, add them, and then turn it into a big multiplication problem. One of the moves that we can actually make here, if I continue up here, is if I have 1 minus 1 over radical 3 divided by 1 plus 1 over radical 3, I can multiply both the top and the bottom by a common denominator. That common denominator in this case is whatever the common denominator of these bottom terms is. So I'm going to multiply the whole numerator by radical 3 and the whole denominator by radical 3. When I do that, this is going to distribute in to both terms here, and it's going to distribute into both terms down here. When I do that, radical 3 times 1 is radical 3 minus radical 3 times 1 over radical 3. These radical 3's divide out, not cancel out, and that's going to be a 1 divided by radical 3 times 1 down here in the denominator is radical 3 plus, again, they divide out, and I get positive 1. We could go even further by rationalizing our denominator down here, but I don't need you guys to do that. In fact, down the road in calculus, a lot of the times we're okay if you even stop here. And on the AP test, they even let you stop here. So hopefully you guys are able to get to this answer, and we're able to evaluate tangent of pi over 12 as radical 3 minus 1 divided by radical 3 plus 1. At this spot, we're going to move on to our fourth example. So I'm going to erase this all here. On my fourth and fifth example that I'm going to do today, we're going to take each of these formulas and we're going to use them in reverse. And you go, what does that mean? That means essentially I'm going to be starting on the right side of my equation, and I'm going to be moving to the left side of the equation. So, and I'll show you what I mean by an example. If I'm trying to find the value of, what am I doing first? Sine of 42 degrees times cosine of 12 degrees minus, cosine of 42 degrees, sine of 12 degrees. You'll notice this is very difficult for us to evaluate something like this. We don't know what sine of 42 degrees or cosine of 12 degrees is. If we had a calculator, we can get that. But if we wanted to get an exact answer, we're unable to do it this way. So what we're going to do then is use one of these sum or difference formulas, but in reverse. When I say that, what we're going to look for is a pattern. So if you look at those 6 formulas and see which one of them lines up, maybe you'll see this, you'll recognize that this looks an awful lot like sine of u, cosine of v, minus cosine of u, sine of v, where u is representing my 42 degrees and v is representing my 12 degrees. This formula tells us that this would equal sine of u minus v. So in this scenario, this will equal sine of 42 degrees minus 12 degrees. Well, at this spot here, remember we can't distribute that in, but these are in parentheses, so we can subtract 42 minus 12. And when I do that, I get sine of 30 degrees. You'll notice conveniently 30 degrees is something that's on our unit circle, and sine of 30 degrees is 1/2. So in this case, then we used a sum or difference formula in reverse. And I'm going to have us do it one more time for example number 5, and that'll be it for today. So let me erase this. For example number 5, here's our last one. We're going to do cosine of 25 degrees times cosine of 20 degrees minus sine of 25 degrees and sine of 20 degrees. When I look at something like this, before I get started, what I want you guys to do is pause the video right now. You guys try to figure this one out. And then if you finish the problem or get stuck, then unpause the video. Alright, welcome back. Hopefully you were able to get the answer. I know when I look at this one, what I recognize that this looks an awful lot like cosine of u, cosine of v, minus sine of u, sine of v. And remember that this formula is the sum formula for cosine, because this is the sum of cosine of u plus v. Remember, cosine is cranky, so the positive turns into a negative. When I do that, that means that this will equal cosine of my two angles being added, 25 degrees being u, plus 20 degrees being my v. 25 plus 20 is 45 degrees, and cosine of 45 degrees is radical 2 over 2. At this spot, we just finished our first online lesson together. I hope you guys made it through, that I didn't talk too fast or I wasn't too boring. What would be helpful for me at this point, before you guys start on ST-1 in this assignment, is if you guys would do me the favor and right below there's like a thumbs up. If you click that thumbs up, let me know that you're okay with this. And then below that, write a comment. Either like, hey, that was great, I get it, or could you re-explain problem number 3, or you did problem number 2 the wrong way. That would be really helpful as feedback for me. And until then, I'll see you guys next time on my next video.